Dear students, in this video, I am going to explain the most important theory of gases, that is, kinetic molecular theory of gases. Let me explain the main postulates of this theory. The first point is, gases consist of large number of tiny particles called molecules. Second point, gaseous molecules moving randomly in all directions with different velocity during their random motion. They collide with each other and also with the walls of the container. Third point, collisions of gas molecules are perfectly elastic. Their total energies remains constant. Fourth point, gases exert pressure due to the collisions of the particles with the walls of the container. Fifth point, the actual volume of the gas molecules is negligible in comparison to the total volume of the container. Sixth point, there is no force of attraction between the particles of gas at ordinary temperature and pressure. And last and final point, seventh point, average kinetic energy of gas molecules is directly proportional to the absolute temperature, that is, Ke is directly proportional to capital T. So let me explain these points with examples. The first point, gases consist of large number of tiny particles called molecules. So the first point is always indicates any gas contain molecules. Here we assume the molecules are in spherical shape and they are in different directions. So the molecules always moving randomly in all directions. Second point, the gaseous molecules moving randomly in all directions with different velocities during their random motion. They collide with each other and also with the walls of the container. If you observe this video, you can see the gas particles are moving with each other and collide with each other and also with the walls of the container. Next point, gases exert pressure due to collisions of the particles with the walls of the container. Let me explain this point with one example. Gas particles exert pressure when they collide with the walls of the container. For example, if you blow air into a rubber balloon, the collision particles of air with the inside walls of the balloon will cause it to expand. The collisions cause an outward push or force against the inside walls. Therefore, due to the collisions of particles with the walls of the container, gas exert pressure. Next point, collisions of gas molecules are perfectly elastic. Their total energies remains constant. This is very important point. On the left side video you can see here the two balls are collide with each other. Before collision and after collision the shape of the balls remains constant. But here in the right side video, when the two vehicles are collide with each other, after collision the shape of the vehicles cannot be retrieved. So therefore here the two balls are in elastic collision and vehicles are inelastic collision. That is the difference between elastic and inelastic collisions. Gas molecules always have elastic collision. Next, the actual volume of the gas molecules is negligible in comparison to the total volume of container. This is very important point. On the left side diagram you can see the gas particles are in large distance. The volume of the container is equal to volume of the gas. On the right side diagram, if you arrange the particles in systematic order, they occupy a small volume called actual volume. It is very small, isn't it? So therefore the actual volume is negligible comparing to the volume of the container. Next point, there is no force of attraction between the particles of gas at ordinary temperature and pressure. Here I can tell you the ideal gas, there is no force of attraction between the molecules. The molecules are free to move, but as far as the real gas is concerned, there is always an attraction force between the molecules. I will explain what is a real gas and what is ideal gas in the next video. Now, kinetic molecular theory of gases always refers ideal gas, but in our nature we have only real gases. If you change the certain temperature and pressure, the real gas changes into ideal gas. So therefore, according to kinetic molecular theory of gases, no force of attraction between the particles of gas Okay, next let me explain the next point, that is the last point. Average kinetic energy of gas molecules is directly proportional to the absolute temperature. Ke is directly proportional to capital T. Ke means kinetic energy is directly proportional to capital T. T means absolute temperature, which is measured in Kelvin scale. So here is in the diagram cool air and hot air. So if the cool, that therefore the temperature is very less, the kinetic energy of molecules is also very less. That means the particles are moving very slow. When the particles are moving very slow, the kinetic energy of mv square, v is less, so ke is also less. When the hot air, if you give some energy to the molecules, if you give the heat energy to the molecules, the kinetic energy definitely increase. So therefore, if you give the temperature to any gas, the molecules moving with high speed and the kinetic energies definitely increase. So kinetic energy is directly proportional to temperature is very important point according to kinetic molecular theory of gases. So thank you so much. This is very important question in gaseous state. So states of matter, gaseous state in chemistry. Thank you so much. Please subscribe.